So in this video, we're going to be solving a trigonometric equation, linear in sine and cosine. So we've got our equation right here, and it's going to be on the interval from 0 to 2 pi. Okay, so I'm going to try to square both sides. So I'm going to square sine theta plus cosine theta. I'm going to square 1. Now, anytime you square identities, you could produce extraneous solutions. So just keep that in mind. To check for extraneous solutions, whatever solutions you get, just plug it back into the original equation. If it works, great. And if it doesn't work, then you disregard that solution. Okay? So I'm going to square here. That way I can get some sine squares and cosine squares and maybe something to pop out. So this gets me sine squared theta plus 2 plus 2 sine theta cosine theta plus cosine squared theta equals 1. Now, sine squared and cosine squared, that's really useful. This is just 1. Okay? So this becomes 1 plus 2 sine theta cosine theta equals 1. If I subtract 1 from both sides, I get 2 sine theta cosine theta equals 0. Divide by 2. And so what do I have? The sine of theta times the cosine of theta equals 0. Now, using the zero factor property, that means either sine theta equals 0 or cosine theta equals 0. And so from 0 to 2 pi, this is going to be theta equals 0 and theta equals pi. This one is going to be pi over 2 for theta and 3 pi over 2. So since we squared everything, we're going to have to check it to see if it works or not. So I'm checking in my original equation, sine theta plus cosine theta equals 1. So this is going to be what? This is going to be, if I plug a 0 in, that gets me sine 0 plus cosine 0 equals 1. That's 0 plus 1 equals 1. That's true. So this is a good solution right here. If I do sine of pi plus cosine of pi equal to 1, that's 0 plus a negative 1 equal 1. That's an extraneous solution. That doesn't work. Negative 1 doesn't equal 1. Let's try pi over 2. So sine pi over 2 plus cosine pi over 2 equals 1. That's 1 plus 0 equals 1. That's a true. And sine 3 pi over 2 plus cosine 3 pi over 2 equal to 1. That's negative 1 plus 0 equal to 1. That doesn't work. So my answer, the solution set, is 0 and pi over 2. Okay? 0 and pi over 2 here. Now, there is an alternate method. If you want to use this method, great. What we just did, there's no big deal using that. But if you want to use this other method, and it makes sense to you, great, use it. But so here's the other option too on solving this type of problem. So sine theta plus cosine theta equal to 1. Now, I'm going to divide everything by the square root of 2. So I divide everything over here by square root of 2, divide everything over here by square root of 2. And you might be thinking, well, where in the world did that come from, right? So that's the hard thing about using this. But if I do that, I'm going to have 1 over the square root of 2 times the sine of theta plus 1 over the square root of 2 times the cosine of theta, which is equal to 1 over the square root of 2. Now, why is this good for us? This maybe is starting to get you to think of a sum or difference identity. Okay, so why is that useful? Because 1 over square root of 2 is actually square root 2 over 2. Okay, and that's square root 2 over 2 equals square root 2 over 2. Now, square root 2 over 2 is actually sine of pi over 4. Okay, and square root 2 over 2 is also cosine pi over 4. Okay. So now we've just built this backwards. This is equal to the sine of pi over 4 plus theta. Okay. Equals square root 2 over 2. So kind of a little bit of trickery going on here. So what am I going to do at this point? Well, if my interval is from 0 to 2 pi, okay, there are 2 angles for which this can work. So sine of something equals square root 2 over 2. Works here and works here. So at pi over 4 and 3 pi over 4. Okay, so that means that this pi over 4 plus theta can equal pi over 4, or it can equal 3 pi over 4. So to solve for theta, theta is going to be 0 here, or theta is going to be subtract pi over 4 from both sides. You get 2 pi over 4, which is pi over 2. Okay, and then those are your 2 answers right there. Now, if that's great for you, good for you, you got it going on. There is a formula. This formula here, in general, if I have a times the sine of theta plus b times the cosine of theta equals c, so a, b, and c are just numbers. So a, b, c are constants, and either a is not equal to 0 or b is not equal to 0. So as long as at least one of them is non-zero, okay? So at least one of them has to be non-zero for this formula to work. The formula, okay, this is going to be a little bit complicated. Dividing everything through by square root a squared plus b squared tells me that I have a over square root a squared plus b squared sine theta plus b over square root a squared plus b squared cosine theta equals c over square root a squared plus b squared. Okay? So there's some unique angle, phi, okay, such that phi is between 0 and 2 pi, for which the cosine of phi equals a over square root of a squared plus b squared, and the sine of phi equals b over square root a squared plus b squared. Now, why in the world is that true? Well, if I draw a triangle, okay, and I've got my A and my B, then the Pythagorean theorem says a squared plus b squared equals c squared. So that hypotenuse C is equal to this right here. That comes from the Pythagorean theorem. A squared plus b squared equals c squared. Okay? And so this is some phi right there. So the cosine of phi is adjacent over hypotenuse, right? And the sine of phi is opposite over adjacent over hypotenuse, which is opposite over hypotenuse there. So that's, just basic right triangle trigonometry going on there. This is the scenario for b greater than 0 and a greater than 0. Okay? So if that's the case, then this equation becomes the sine of theta times the cosine of phi. So I'll replace this nasty thing with cosine phi, and then plus the cosine of theta times the sine of phi. So this nasty thing gets replaced with the sine of phi, and that gets replaced with the cosine phi. Okay? And so now I see that this is equal to the sine of theta plus phi. Okay? And that's all equal to this c over square root a squared plus b squared business here. Okay? Now, one thing to note, what is the longest side of a right triangle? It's the hypotenuse. So what do I know? The absolute value of c, okay? If the absolute value of c is greater than the square root of a squared plus b squared, okay, then the sine of theta plus phi is greater than 1, or the sine of theta plus phi is less than -1. And the equation has no solution. So if you see that this numerator in absolute value is greater than the denominator, then there's no solution here. Okay? Because if you think about sine can only produce values that are stuck. The sine of something has to be stuck between -1 and +1. But if c is bigger, if the numerator is bigger than the denominator, then that number would be greater than 1. And therefore it's out of the range. So then there'd be no solution. Okay? So we have to know that c is less than or equal to the square root of a squared plus b squared. And if this is the case, then the solution to a sine theta plus b cosine theta equals c. So if you're just looking for the formula, here's the formula right here. Okay? Then the solution is theta plus phi equals sine inverse of c over square root a squared plus b squared, or theta plus phi equals pi minus the sine inverse of c over a squared plus b squared.